In this video, I'm going to show you how to deploy your very first application to Kubernetes. This is a hands-on session, and I want you to do this exercise with me because ultimately videos don't teach you stuff. Doing things teaches you stuff. So today we are going to deploy a backend application, a REST API, to our Kubernetes cluster. You will create Kubernetes objects to run your application and actually see pods in action. You will also learn how to effectively use Kubectl to deploy our application, fetch its logs, roll out updates, change configurations, and get whatever information you need about any of the Kubernetes objects in your cluster. Welcome to the 4th chapter of Kubernetes from Zero to Hero. My name is Raghav. Let's get started. Okay, I'm on my local system now, and I have opened up my repository. So in this exercise, we are going to deploy a simple Golang application, which is a REST API, which exposes like two very simple endpoints, ping and hello, that's it. You don't need to know Golang in order to run this application. Like, I just wrote it because it was convenient for me, but you could be writing this application in any language of your choice, or you could even just be using Nginx, it doesn't matter. What matters is that we are going to take an application, a REST API, and package it into a container and then deploy it to Kubernetes. And we're going to see how. So this is the repository in which I store all my code, and the link to this repo is also in the description, so you can just go to it. And so now let's go and check out the application that we're going to deploy. It's under Kubernetes chapter 4. This is the application, right? This is the Go app for chapter 4 that we're going to deploy. Very simple, as you can see. There's just the main.go file, and there's very bare minimum code, right? We register two API endpoints. One is ping and one is hello. And we register the respective controllers for them. And as you can see, even the controllers are very simple. When we receive a ping request, we just log that there was a ping request that was invoked. And then we just send a pong back as a plain text response, right? Same with hello. We just log that there was a endpoint invocation, and then we just send back a plain text hello world. After registering these two endpoints, we just create another log that, okay, the server is now ready and now running. And we just bind our server to the localhost on port 8000 and we start it, right? That's all. Bare minimum. Go mod, again, there is nothing. It's the bare minimum, which is just like the package declaration and the Go version to be used. But as you can see, yeah, nothing significant here. And finally, there's the Docker file, which is how we are containerizing our Go application. Again, a very simple Docker file. We just inherit from the Golang base image. We create our own SRC directory where we put our code. We compile that code into the final application executable. We also tell Docker as we also set sort of a documentation in our image that port 8000 is probably exposing some sort of a service. So whoever is running our Docker container, they get to know, okay, there's potentially something being served on port 8000. So you probably would like to publish port 8000. And finally, we have the command, which is by default what's going to start running once we start the container, unless we explicitly do something else. But since the whole point of this container is to just run this app, so yeah, just let it be. So yeah, the moment we run the container, it'll start running our application, which is just the REST API. So this is it. And this is the application that we are going to package into a container, and then we are going to deploy to Kubernetes. Okay, now I'm on my terminal inside my system. The first step is going to be that let's clone this repository onto our local and build the container out of this application. Okay, few things. Yeah, you should already have Minikube installed. You should already have Docker installed, but I think you've got that covered. So let's go. I'm already inside my directory. There is nothing fancy in this directory. And this is where we're going to clone our stuff. Okay. Yeah, now I have the code on my local. The first thing I want to do is, of course, create a Docker image using the Docker file and using all these assets, right? As you can see, currently on my system, there is no Docker image apart from the Minikube image, which is fine, as we saw in the previous video. So let's go ahead and create the Docker image for this thing. There we go. Okay, so I just create a simple Docker image out of the current Docker file. and I call it hello go. Okay. Yeah, okay. It seems that hello go is now created on my system. Okay. Then it is time to run the app. I'm going to clear the screen. Okay, so I'm running this app. I use the RM option so that once I exit the container, it automatically gets deleted, doesn't stay on as garbage on my system. And I am also publishing the port, right? So I'm telling Docker that once this container is running, I would like to expose the internal port 8000 onto my local host also so I can interact with it. And I'm going to be using the hello go, which is the image. Let's run it. I can see that I got the first log, which is Raghav server now running. So how about we test it out? Okay. Yeah, my container is running. Port 8000 is exposed. So curl localhost port 8000. Now remember that I have two API endpoints. One is ping, one is hello, right? I don't define what will happen if I just try to make a API and hit on the home directory itself, which is just slash, right? So it'll just give me a 404, which is fine, expected. But when I do a ping, it gives me a pong. It gives me a pong, and I also see a log over here that ping endpoint was invoked. Similarly, hello gives me back hello world along with a hello endpoint was invoked log, right? So this means my application is working perfectly. My Docker container is working perfectly. All of this stuff is good, right? It's already sorted. Now, of course, it is time for me to run this Docker container in Kubernetes. Okay, then let's exit. Let's end our container because we've already tested it. Nothing. Now, in the previous video, we saw that how to run a Kubernetes cluster on our local using Minikube. I can run the Kubernetes cluster, but how do I interact with that Kubernetes cluster? Like, what I mean is, if I would like to tell Kubernetes, hey, take this Docker image that I have and run X number of containers on it, right? How do I tell Kubernetes? The way for me to do it is I need to talk to the Kubernetes API server, right? And I could make direct API calls, but there are tools out there which make my life a lot easier. The de facto tool that we use here is called Kubectl, right? It's a command line application that is created and maintained by Kubernetes team itself. It's the official client, right? And it is very powerful. It gives you access to pretty much all of Kubernetes API's features, and you could just interact with the API in whatever ways you want. So what we are also going to do is we are also going to install Kubectl on our local system so that we have a very efficient way of talking to Kubernetes cluster once it's up. In order to install Kubectl, it's a very, very simple step. There's nothing complicated here. Just go to Kubectl installation. The Google search will send you to Kubernetes docs, and there are steps for all the major platforms on how to install Kubectl. Since I am using Mac, so I'm just gonna open up the Mac, but of course, as you saw, you could just go to your respective platform and go to the documentation of your respective platform and just install Kubectl as you want. I could be doing these steps, but there is also, since I'm on Mac, there is a very easy way for me to do this via Homebrew, which is just brew install Kubectl, right? So that's what I pretty much did. Okay, so I'm not gonna run it because I actually already have Kubectl installed, but this is all. It's pretty much just one command that you need to run and you will have Kubectl on your local machine. Once you install Kubectl, it's gonna look something like this. Yeah, so this is Kubectl installed on my system. Yeah, so I can do Kubectl version. Apparently it's deprecated, but yeah, who cares? Now, once I have Kubectl installed, of course, as you can see in the help message, there are plenty of things that I can do with it, right? It's basically the front end where I just invoke a command, give some data, give some parameters to it, and accordingly, Kubectl talks to the Kubernetes API to make things happen. right? The important question here is, how does Kubectl know which API to talk to? Where is the Kubernetes server, right? Because for this exercise, my Minikube Kubernetes cluster will be running on the local host at some port. But in production environments, my Kubernetes cluster could be running in AWS. It could be running on a bare metal server in some data center. How does Kubectl know where is the Kubernetes API server? Actually, we are the ones who have to tell Kubectl. We have to configure Kubectl so that it knows where the Kubernetes cluster is. It can point to that cluster, the exact address and port, and that's how Kubectl talks to the API server, right? In case of Minikube, for example, when we will run our Minikube cluster, it will automatically configure Kubectl to point to the right cluster. And I also just want to show you, when I go to my home directory, inside my home directory, there is going to be a directory called .cube, right? It may not be there by default, but when you install Kubectl, it generally gets created, right? .cube is the directory which will contain configurations for Kubectl. Okay, as you can see right now, there is nothing in here, right? But once you start working with Kubectl, there's normally at least a config file. That config file is what contains the configuration for Kubectl. It tells Kubectl which Kubernetes cluster it is pointing to currently, right? And we can manipulate that using a config command in Kubectl. Let's now start the Kubernetes cluster on our local machine using Minikube. And then we will also see that there is a config file over here, right? Currently it's empty, but Minikube. So what I'm doing here is I'm going to start a Kubernetes cluster using Minikube on my local, but I'm going to give it 3 nodes. If you remember in the previous video, we just did a default Kubernetes cluster which just had 1 node, which was running both the control plane components and the worker node components. And at the end of that video, I also posed the question, how do you create a Kubernetes cluster with Minikube with multiple nodes? This is one of the ways, right? You can just declare that I want X number of nodes, and Minikube will just start the cluster with these nodes. Of course, all these nodes are actually just Docker containers which are running on your local machine only, but virtually speaking, they are different nodes and you have a Kubernetes cluster running. Okay. This can take some time. Okay. So it seems like our Minikube cluster has started, and pay attention to the last line. It also says that Kubectl is now configured to use Minikube cluster, and the default namespace is what is in use, right? I'll explain namespaces in a bit. For now, focus on this line. This means that Minikube has automatically configured Kubectl to point to this Kubernetes cluster's API, right? And just to quickly show you, so now there is also a config file present inside our .cube directory, right? So let's see what this config file contains. As you can see, this config file actually contains some interesting data, right? It contains the configuration for Kubectl on how to point to the Kubernetes API server and how to authenticate with it. And any kind of information that the client requires to be able to talk to API is present here. Good. Now you know how Kubectl knows where to reach an API server to. Let's start playing with Kubectl and with our Kubernetes cluster now. First, let's try and get some basic information about the cluster. So this is just me trying to understand what configuration is Kubectl currently using. So as you can see, the current context gives me Minikube. Current context means what is the exact Kubernetes cluster that it's pointing to. And we are calling the cluster as Minikube. This command cluster info gives us a little more information about the cluster. As you can see, the control plane is running at localhost at this particular port. And then there's core DNS, which we're going to talk about more in later videos. Let's get some more information. So get clusters command from config can give us what all clusters exist in our local configuration, right? And then we could pick one of the clusters to point to. So this way, like, there could be multiple Kubernetes clusters running at different places. Maybe like one is running in Azure, one is running in AWS, and one is on bare metal, and one is running locally. And we could still, work with these multiple clusters by just simply switching to the appropriate cluster that we want to talk to. So right now I only have one cluster configured on my local Kubectl configuration, which is just Minikube, which is fine, right? And that's what Kubectl is pointing to. So all is good. Now, enough about local configuration. Let's try to get some information about the Kubernetes cluster that's running. So get nodes command gives me the set of nodes that are running as part of my Kubernetes cluster. As you can see, there are three: Minikube, which is control plane, Minikube 2, and Minikube 3, right? So Minikube is being treated as the control plane node, which is probably running all the control plane processes, and 2 and 3 are the worker nodes, which are ready to run more workloads. Another thing that we saw earlier was namespaces. And if you remember, we saw that currently we are using the default namespace. So in Kubernetes, a namespace is a logical grouping of resources. Each namespace is isolated from the others, and the objects you create inside a particular namespace only need to have unique names inside of that namespace. For example, you could create a pod called test in the default namespace. Then you could create another pod named test in a different namespace. But if you try to create it again in the default namespace, that will be rejected by Kubernetes, because there's already a pod called test. But not every Kubernetes object comes under namespace scope. For example, a node is a cluster-wide object, so it doesn't come under a namespace, but a pod is inside the scope of a namespace. Namespaces are very useful when you have a large number of users or applications in Kubernetes and you need to start creating boundaries. So if in your organization there are several teams sharing the production Kubernetes cluster, right? They could all get their own namespace to work inside with their own resource quotas. So namespaces also allow you to divide the cluster's resources amongst multiple users. And when you create a fresh Kubernetes cluster, there are a few namespaces that already exist. You can use Kubectl get namespaces to see all of them. I'll show that to you in a bit. Kubernetes itself doesn't dictate you how you should or shouldn't use namespaces. That depends on how you want to divide your cluster's resources. But it's a very common practice to have one namespace per team or per project in your organization. You can also go to Kubernetes documentation to learn more about namespaces and how to create and, some of the default namespaces that already exist and which one you should be messing around with, which one you should not be messing around with. Okay. So back to our terminal. These are our nodes and we are currently in the default namespace. Let's also quickly see the namespaces, right? Get namespaces gives me all the namespaces that currently exist in my Kubernetes cluster. So as you can see, these are the pre-existing namespaces because I did not create anything. I just created a new cluster in front of you. So these already exist. If you want to see the current namespace, you can do config view and then search for namespace. That will tell you that we are currently on the default namespace. Okay, let's launch the Minikube dashboard so that we can visualize some more information about our cluster. Here. So now I'm inside my Minikube dashboard. If you've seen my last video on Minikube, you are already very familiar with this dashboard. The main thing that I want to show you here is nodes. If we click on nodes, you can see that now this time around, there are 3 nodes that we can see, right? Again, this is something we've already seen in the output of Kubectl, but for some use cases, just seeing things in UI is a lot more pleasing to the eye. So Why not? Minikube 02 and 03, right? If I open up Minikube, the Minikube node has a special tag which says control plane. What this tells me is that this node is being treated as the control plane node, right? And the proof is right here. We can see that there are control plane processes running on this node, like the API server and the controller manager, scheduler, all these things, even etcd, right? So all the control plane components we talked about in the architecture video are actually running right here in the Minikube node. If I go to the other nodes, for example, 02, you can see that that tag does not exist here. And more importantly, if you just check out what processes, what pods are running on it, you can see that it is actually only running processes which are meant for worker nodes. It's not running anything for control plane. Good. And just to also see that currently there are no pods running. These are the pods that we as users submit to Kubernetes to run. And because it's a fresh cluster, of course, there's nothing running, right? So it is time for us to run something on our Kubernetes cluster now that it's up, right? Before I run anything on my Kubernetes cluster, I would like to publish my Docker image somewhere on a repository so that when I run my pods inside my Kubernetes cluster, the worker node knows where to pull that image from in order to run that container image inside the pod, right? So, and at the moment, if you remember that Docker image is only available locally on my system. So what I'm gonna do is so this is the Hello Go image, which is currently only on my local. So I'm going to upload my Hello Go image onto Docker Hub inside my repository. Here is my Docker Hub. Docker Hub, you can just create an account for free and host your own repositories. Of course, there are limitations to the free account, but for this exercise, it works perfectly. And even for your development and testing purposes, it will work perfectly. And you don't have to spend any money for that. So as you can see, I have already created a new repository for myself in Docker Hub, which I call Hello Go, right? But at the moment, it is empty. There is nothing over here. And this repository is where I'm going to publish my Docker image. And from here is where the worker nodes will also pull the Docker image to run inside the container. So let's do that now. Let's publish our Docker image. Now, first thing, just Docker push Hello Go is not going to work because we need to know the exact path to push to, right? By default, Docker CLI publishes all images to Docker Hub only. So I don't need to change the default configurations. That's good. And my Docker CLI is also authenticated to my Docker Hub account already. So I also don't need to take care of the authentication right now. But of course, if you're just setting things up, you will need to authenticate to your Docker Hub repository as well. For me, I must push to duaragavait/hello go and then tag name, right? So, So I push my duaragavait/hello go latest to the Docker repository, but currently I don't really have an image like that. I don't have an image which is called duaragavait/hello go. So this command is going to fail. Instead, what I do is I'm going to just create a new image out of my existing image and just give it a new tag. So Docker tag source image latest 2. No, where is it? Here it is. Latest. Good. Now I have an image called duaragavait/hello go, which is actually, it's not different. It's the same as this Hello Go image. You can see image IDs are the same. It's just a different tag, right? And now I am ready to push. Docker push. This step can take some time because you're pushing like probably a 1 GB file to Docker Hub. Once my image is pushed, then if I go back to Docker Hub and I refresh, there. So now I can see that my image has been pushed as latest. And this is what it contains. As you can see, these are the commands from my Docker image, right? The CMD app. So that means my image is now in Docker Hub and it is ready to be pulled. So, and since my Docker repository is actually public, I haven't kept it private. Even like if you want, you could try and pull my image right now. You could just do docker pull duaragavate/hello go latest, and you will see actually you were able to pull this image right now, right? So that's why even my worker nodes will not have any trouble downloading this image while running the pod. But of course, in a production scenario, when you're working at a company, you will probably be using a private repository, and there will be some authentication mechanisms involved in between in order for your worker nodes to be able to pull these images. So make sure that is sorted out. Okay, so our image is now published and our Kubernetes cluster is running and everything is perfect. We are now ready to deploy our application to the Kubernetes cluster. So we know that the smallest unit of compute in Kubernetes is a pod, right? So if I want to run an instance of my application, I run it as a container inside a pod in Kubernetes. But let's say in production, I want to deploy an application, right? I'm not going to deploy just one container of that application. I'm going to deploy several containers across different machines, across different data centers, and maybe even across different geographic regions for high availability and for handling the load appropriately. So I would like to create multiple pods of my application inside Kubernetes for high availability. Now, it is a very unwise thing to create each pod manually and then manage these pods separately. It's just too much of a hassle and it's too much manual work. So Kubernetes provides a higher level of abstraction on top of this, which is called a deployment. A deployment is basically a configuration you write to describe what exactly you want to run as part of your pod. You can sort of define a template for these pods. And then you can also specify how many such pods you want to run. The deployment manages all these pods now, so I don't have to take care of them manually. It also provides automated rollouts and rollbacks for the app without any downtime. You just need to change the configuration. It takes care of updating things for you. So deployment is a great way for me to run and manage a long-running application, like a microservice. So let's do that. Let's create our deployment. Okay, let's understand this command. First, we do a kubectl create, right? Create allows us to create different objects in Kubernetes. Of course, we are creating a deployment here, and here is the name of the deployment. I'm just going to call it Go app. Okay. And finally, for now, there is only one main parameter that I do need to give to this deployment. There are many other configuration parameters I can supply to this deployment. For now, it's good enough that I just give it that, okay, I have one pod that you're going to run is going to have one container which has this image, right? Which is duaragavate hello go. And I'm also just going to, for clarity, specify the latest tag. And what this means is the moment I create the deployment, the moment the pod gets scheduled on one of the worker nodes, the worker node will pull this image and it will start running the container inside that pod. Okay, so let's create this. Yeah. Okay, I can see there's one deployment, but it's not yet up and running. Yeah. So I can get pods like this, and there's one handy feature I often use, which is get pods and watch. This way, what kubectl will do is it'll not exit, but instead it'll keep updating as anything changes in the pods, right? So right now we are looking to get the new pod ready, right? And I'm guessing right now the pod is busy downloading the Docker image, and once it's downloaded, it'll just fire it up and start. Let's give it a couple of minutes. Perfect. Okay, so now we can see that our pod, which was not ready, is now ready, right? And it's now running. So this is the final state. When a pod lifecycle status says running, it means our pod is running as expected. So I'm going to exit the watch command. So there is a kubectl get command, which gives me a summary of what all objects exist in my Kubernetes. Now, if I want more specific details about any of the objects, I can do kubectl describe. So for example, here's my pod name, right? Kubectl describe takes as input what kind of object you would like to describe and then the name of that object. And so that name, since that name is unique within the namespace, it knows exactly what to display to you. So let's try that out. This pod. Now this produces a lot of output. So one handy trick I often use is just stream all this output into Vim so that it's easier for me to navigate. And here it is. This is all the data that I have about this particular pod that is running. And this pod is actually running my application right now. You can see a bunch of things. Here's my image specified as I specified, right? We would also like to see the node. So if you see line 5, we are running this pod on node 2, Minikube 02, right? So this was a node determined by the scheduler. Good. And yeah, there's lots of other information available over here for us to go through. And you can also see some logs, but of course we'll get them in more detail later. Now, there's one more thing I want to mention. Right now, the way we created a deployment for our application was by using a kubectl create command, right? This is convenient because it's a small command, but as I told you earlier, a deployment is a whole template. It's a template of a lot of different parameters that you can configure to tell Kubernetes what is your desired state for your application. So there could be potentially plenty of parameters for you to configure. Right now, the only parameter I gave was image, but here's an example deployment, right? So as you can see, there are a lot of different parameters that can be given. It's not just the image. Image is just one of the parameters, but there are many configurations you could give. So if you have so many configurations, it becomes very inconvenient to have all of this as a command, right? That's why Kubernetes also has a concept of manifests, which is manifests are basically YAML files that you write where you can specify all your configurations inside a file, right? Instead of having to specify all of this in the command. So you write a manifest like this as a YAML file, and then you can specify all the configuration. And then what you can do is you can supply kubectl with your manifest file. You know, you could simply say kubectl apply and my manifest.yaml, something like that. And kubectl would take that and take the entire set of configurations in your manifest file and just apply them. So in a manifest file, you could specify the exact configurations, the desired state for not just a deployment, but for any Kubernetes object. For example, here, the kind says deployment, which means this manifest is for a deployment, but you could be creating a manifest for storage, for a persistent volume claim, for a service. And yeah, of course, all these terms will be more clearer in later videos, but that's the idea of manifest. The added benefit of a manifest is that now you're writing all this code as a file. And of course, you can commit these files to version control systems. That way, you maintain a complete history of how the desired state of your Kubernetes objects changed over time. And you know exactly what the current desired state is, because you can just see, for example, on the main branch, what is the current manifest code written. And you know that that's exactly the desired state of Kubernetes objects. So yeah, we are going to be using manifests a lot more in later videos. For now, because it was more convenient for us to just use kubectl directly, I just went with that. Now, let's also just check out the Kubernetes dashboard once more. Here it is. And yeah, now you can see that since I deployed my application, I now have some workloads mentioned over here, right? I can see my deployment, which is Go app. And as part of that deployment, here is a pod, and there is also a corresponding replica set. A replica set ensures that a specific number of replicas of my pod are running at any given time. What I mean by replica is that all these pods are identical. They are created from the same template. They all run the same things. So they're all replica pods. If I say that I want 5 replica pods for my application, this replica set ensures that there are 5 pods running at any given time. If I increase that number to 7, it will add 2 new pods. If I decrease that number to, let's say 3, it will subtract 2 pods. But deployment is a higher level of abstraction on top of this. which provides more features to manage your app. So generally, you will not directly deal with the replica set. Rather, you will create a deployment and that will internally manage the replica set for you. And this replica set in turn ensures the desired pod count. So don't be confused about where this replica set came from. My deployment created it internally. Okay, so this is the deployment, right? There's some basic information, but of course we can get a lot more information if we need from Kubectl. Yeah, again, you can use the describe command of Kubectl with any Kubernetes object and you will get whatever information is available, right? So you can see that in the deployment, one special field is the replicas, which is the number of pods I want, right? So by default, because I did not specify anything, by default, the number of pods is 1. So it comes as 1 desired and 1 total, right? So everything is as desired, which means the deployment is stable and there's nothing wrong. But of course, if let's say the pod crashed, right, then it would suddenly become 0 available, but 1 desired. And so the controller manager, the deployment controller would come into action, and then, you know, the scheduler would come into action. So a new pod will get scheduled and then the worker node will take it up and apply it, and the whole cycle repeats. And yeah, there's a bunch of other information that you can see. These are all the configurations that I could change about a deployment. And similarly, looking at my pod, it is scheduled on M02 node. There are some logs. Okay, so enough talk about how the pods are deployed. It's great to see that Kubernetes tells me that my application is deployed. Awesome. But of course, this is not enough for me, right? I would like to interact with my running application because that's the best way for me to validate that yes, everything is going perfectly well and I'm able to interact with my API. So when we deploy an application to Kubernetes, by default, these pods are running on an internal Kubernetes network, which is an isolated network. So by default, these applications are not automatically exposed to the outside world. And right now, if you see, the Minikube cluster is the Kubernetes cluster, and anything outside of it is the outside world, which means even the rest of my system is the outside world for Minikube cluster. So that means I cannot just directly try and interact with my application right now because the pod is not accessible to me. There is no network path. Let's see how to actually reach to my application, which is running on an internal Kubernetes network. In order for me to be able to reach my application, I have to create a service. So a service is basically, okay, when you run pods that need to expose some functionality over the network for other clients, like a REST API that we have right now, you need to create a service object in Kubernetes for them. A service helps you expose a bunch of pods over a network. Right now, all my pods are managed through my deployment and they're fine by themselves. But each pod has its own IP address, and the problem is pods keep coming and going. So you can't expect all your clients to keep track of all the valid pod IPs at any given time, just so that they are able to talk to your application properly. So service creates a service discovery mechanism on top of your pods and exposes a single, I can say, stable IP address for clients to talk to. And internally, the service then keeps track of all healthy pods and distributes traffic amongst all of them. Again, even a service is a Kubernetes object. So technically, I can also define it inside a manifest file. But our expose command is pretty straightforward. So I'll just use Kubectl for the sake of simplicity. To create a service out of my deployment, I can use Kubectl expose command. This command takes my deployment and creates a service object out of it in Kubernetes. Let's use service like this. Kubectl expose, because in this case, I'm going to be exposing my deployment. So that's what I go with. And my deployment is called Go app. We need to specify the type of service we create. The type determines the exposure of my application. Like some apps just need to be exposed within the Kubernetes cluster so that our apps can talk to them. internal microservices are an example of this, right? Other apps like front-end servers or Nginx need to be exposed outside the cluster for end users to be able to access, right? So we can configure this thing using type. So here I'll set the type to node port, which exposes my service outside the cluster, because that's what we want. We want to interact with the cluster from outside of it. Node port exposes a static port on all the nodes. So I can just connect to any of the nodes on that particular port to talk to my application. Okay. And then I specify the port to be 8000 because that's where our application is ultimately bound. Once I do this, I can do kubectl get services. As you can see, now I have a service named Go app, right? There is also another service called Kubernetes, but that's because that's the way Minikube runs. Minikube runs everything as a pod inside, to run the Kubernetes cluster inside its Docker containers. So you can just ignore this. It's not something you will see in an actual Kubernetes cluster. So technically we only have Go app as a Kubernetes service. And what this means is it is now exposed at a particular port for us to access. Since I've exposed my deployment, my pods as a service, it is accessible over a network to the outside world. And so I'm going to be able to access it. Now there's one important thing that applies to me, but may not apply to all of you. I'm using Mac OS as the platform, and on all non-Linux platforms, Docker containers don't directly run on the operating system. There is a layer of virtual machine in between, because Linux has direct support for containers, but the others create a virtual machine, and via that we run Docker containers. So Docker Desktop, the software which we use to run Docker containers, creates a layer of virtual machine and then runs Docker inside it. What this means is this service is exposed to a particular port, but it is exposed inside that virtual machine. So if right now I try to access this service on the particular port, it'll actually not work because this port is not actually published on my local machine, but rather inside that virtual machine. So because I'm on Mac, I need to create some more mapping so that I'm able to reach the service. But if you're using Linux, you will not face this problem. At this point, you can already access the service. So here is one additional step that Mac users and Windows users will need to do. You will need to use something called the Minikube service. A Minikube service opens up a SSH tunnel between the pod and your local host and opens a browser for you to interact with the app. Let's do Minikube service Go app, right? And there you go. Now Minikube opens up this service in the browser. And of course, since I haven't defined the home path itself, I get a 404. But if I do a /ping, I get a pong. And if I do a hello, I can get a hello world, which means now I am able to interact with my application. And we can also do a quick curl request on this. Okay. Yeah, I can also do a curl. What happened here was that I asked Minikube to create a service for my Go app, and then it created a tunnel. And finally, I can access my Go app on this port on my local machine. And this port is ultimately mapped to my service inside Kubernetes. Awesome. So we were successfully able to launch our application into Kubernetes and also interact with it. Now, how do we access the logs of this application? Every time we make requests to the API endpoints, and even when my server is starting, the application produces some logs. So to gain better visibility into my application, I would like to get those logs as well. So of course, Kubectl also has a very convenient feature for us to access the logs. Let's see how. I'm gonna just, okay. For this, we use the Kubectl logs option. So Kubectl logs allows us to get logs from a variety of different places, from a pod, from a container inside a pod, all containers, and all these different things. So it's a very flexible option to use, right? And this is what we're going to use to get logs from our application pod. We do kubectl logs and pod name, but I don't remember my pod name, so here is my pod, right? So now I can do kubectl logs pod, and here, see, I can actually see my logs over here. There is one very handy feature that I can use. I can use the command follow. What this does is it starts to tail the logs, right? And instead of exiting, this command continues to show me logs as they get produced by the application. So let's try this out once. Now I'm just looking for the next logs. Just go here and okay, /ping. Now keep an eye here. Okay, when I do a ping, a log was produced, and so my follow command did not exit, and instead it just showed me the log here as it got produced. I can do a hello, and that was also produced here. So the follow command is pretty useful because it can give you live logs for your pod. And now I'm just going to exit my command. How did these logs actually arrive here? These logs were produced by my application, but I'm able to see them on my local machine here. Kubernetes actually captures logs from each container running inside a pod and makes these logs accessible over its API. By default, it captures the stdout and stderr streams, which stands for standard output and standard error. When my application writes any logs using the print function, let's say, it is actually writing to the standard output stream by default. So these logs get captured by the container runtime and fed into the kubelet of the worker node. Kubectl simply fetches the logs from the Kubernetes API and displays them as output here. Okay, so far we have only run one pod for my application. But of course, in a production scenario, I would like to have more than one pods. So let's see how we can make use of deployment here to actually scale out our pods very easily without having to create more pods manually. Kubectl scale. Scale allows us to scale out or scale in our pods and create new Kubernetes objects or destroy existing Kubernetes objects. So I tell kubectl that I need to scale my deployment Go app and by how much. So I'm going to set the number of replicas to 3. Right now, the number of replicas in my deployment is just 1. That's why I only have one pod. But the moment I set to 3, let's see what happens. See, there is now order to create 2 new pods. One was the existing pod, but there are 2 new pods because I set the total desired state to 3 pods, right? And now these 2 new pods are coming up, and once they come up, I have a total of 3 pods running and serving traffic. So let's wait. Yep, our pods came up, and now we have 3 pods running. Yep, now I have 3 instances of my application running. And yeah, okay, now I've got 3 pods that exist, right? But check this out. They are on different nodes, right? One pod is deployed to Minikube, another is 03, another is 02. As you can see, these pods are spread out across multiple nodes. The scheduler decides what is the optimal node for my pod to go on. So in this case, I'm guessing the Kubernetes scheduler decided to evenly spread out these pods across different nodes. But also notice that the Minikube node itself is a control plane node. It's running the control plane components, but it is also being treated as a worker node. So the scheduler is scheduling pods also on it. Of course, we can make configurations so that Kubernetes scheduler does not schedule any pods on the control plane node itself. And in a production Kubernetes cluster, you would never run pods on a control plane server. You would only run pods on the worker nodes. Okay, going back, now that we have 3 pods, any requests that I make to my service will now be load balanced amongst all these pods, which means whatever request I make, I don't know for sure which pod will end up handling that request, right? Which is fine because we are running stateless services over here. So any of these could be handling my request and it doesn't matter to me. So for example, if I try to stream logs of just one of these pods, let's say the middle one, right? Okay, I'm now following the logs of this so-and-so pod CQR8Q. Okay, and I'm going to now run the service again. There. This is our new service, right? I'm going to take this. Now, notice that my application is exposed as a service at a single port 6336, right? And if I make a request, I will get a response. But it is the Kubernetes service which is internally load balancing all my requests amongst multiple pods. So, curl/ping. Okay, so I made a ping request and it did go to this middle pod, right? Let's make another ping request. This time I did not get a log over here. Why? Because this request probably went to some other pod. Again, still no request here. Again, no. So you see, in a way, we are load balancing all these requests. And see, I made one more ping request. This time it did come to this one, right? So this is how a Kubernetes service accepts requests from the outside network and then load balances them amongst the multiple pods that are running. Okay, let us now try to make an update to our application. Okay, I'm going to close this service. All right, so I'm in my code folder. I would now like to make a small change to my application and then roll this change out to my Kubernetes application. Let's see how to do that. I'm going to go to main. I'm going to change the response messages. Okay. You can see that I have changed the response messages. This is the idea is that I made some code changes and now I would like to roll this change out as a newer version of my application to my Kubernetes application, right? Let's quit this. Okay. Of course, I made some changes now, which is fine. Now I want to create a new Docker image out of this. So now, this time I can directly create a Docker image as dwaragawait/hellogo, and I can give it a newer version instead of just relying on the default latest version, because yeah, then that will cause confusion. So 0.0.1. Okay, this is the image that I now want to deploy. Let's create this image. Okay. Good. Let's check out. Yeah. Okay. I can see my HelloGo image with 0.0.1 as a tag, and let's push this image. Let's push it. This time pushing should be a little quicker because yeah, Docker caches some layers. Okay. So it looks like my image is pushed. How about we just go and check it out, refresh. Yeah, okay. So I now have 0.0.1 image on my repository as well. And now my main goal is that I would like to roll out an update to my Kubernetes application, which so far has been running the latest image. Okay, just to confirm, right now I'm running the latest tagged image of HelloGo, right? I would like to change this image, update this image to 0.0.1. And right now, the only configuration I am changing in my entire deployment is the image, right? Later on, in later videos, we will also see how we are maintaining deployments as part of manifest files, and then how we'll change configurations within those files and then roll out those configuration changes to Kubernetes. For now, image is good enough. If I just pick up any pod, all pods are running latest. So for this, I use the kubectl set command. Set is used to update a particular value. You use it when you want to change something about the desired state. You want to set a new value for some configuration. Image is what we use for specifying the container image. Deployment / co-app. But now remember that inside a deployment, you have pod, and inside a pod, you can have multiple containers. That's why you need to specify which container you want the image to be updated for. So container equals image. So now what exactly is my container's name? That's what I need to figure out. I don't remember it out of the blue, but I suppose if I can just describe my deployment, I should be able to get the container name. Yeah, my only container running inside my deployment is called hello-go, right? So let's use that. Hello-go, and the image will be /hello-go with 0.0.1. Just to be sure, I want to see wait /hello-go. Yeah, that's what it is. HelloGo 0.0.1. And I can now run this command. And what this will do is it will go to my deployment. It will change this particular configuration. And then we will see that the deployment controller will come into action and make these changes, because we have changed the desired state over here. And of course, if I was working with a manifest file, I would just change this image inside the manifest configuration and then ask kubectl to apply that manifest, and the same thing would happen. Okay. So you can see that my previous pods are terminating and new pods are running. What internally Kubernetes did was to destroy my old pods and roll out my new pods. But of course, any such update is actually done in a rolling manner so that there is zero downtime and we still update all our pods with the new image. Let's see the configuration for the new deployment. Okay, this time I can see that the image specified now is 0.0.1, right? And all my new pods, let's just describe all my pods. Yep, so we can see that all my new pods are running the new image. Exactly. Good. Which means if I now interact with my API, I should get the new responses. So why not try that? Okay. Let's try ping. I get a pong with an exclamation. If I try hello, I get a hola instead of hello world, which means my update was successfully rolled out in my pods. This way, I have rolled out my updates without any downtime in Kubernetes. And that's it. We just deployed our first application. We managed to roll out updates to it, scale it out, get some information about it, visualize it in the dashboard, fetched some logs to get more visibility into our application. And we worked with a bunch of Kubernetes objects like deployments and pods. The final step is to clean up everything. So first, we need to see what all exists inside our Kubernetes objects, right? Especially with regard to my this application. So of course, here is there's a bunch of stuff I can visualize. There is a very handy command which is called Kubectl get all. This will produce all the objects inside my cluster in my namespace. And these are the things that I'm trying to now destroy because I want to clean up my cluster and I can then shut down everything. So first things first, I delete my deployment. The moment I delete my deployment, all the pods inside my deployment automatically get deleted as part of it. Good. Let's see what all remains. Yeah, so if you can see, the only thing that now remains is the service, because service is a separate object and it's not tied to the deployment. So just because I deleted the deployment doesn't mean the service will also get deleted. So I must do it on my own. And there you go. The service has also been deleted, right? And now nothing remains inside my Kubernetes cluster. I am also going to shut down my Kubernetes cluster and just delete the whole thing. So if I just check the status of my Kubernetes cluster, I have one control plane node and 2 worker nodes. I'm going to stop. Then delete my cluster. Yep. After this, there's nothing left. No containers running. So now I have just cleaned up my entire Kubernetes cluster, right? And that's it. We deployed an entire application, then just removed it, cleaned up our entire Kubernetes cluster, and also cleaned up our system. Beautiful, isn't it?
That was a lot, but I really hope you completed all those steps because once you do, you unlock superpowers. Now let's say I don't want any of my pods running on a particular node, let's say Minikube 03 because it contains some old hardware and I don't like that machine. How do I tell Kubernetes to never run my pods on Minikube 03 node? Your assignment for today, should you choose to accept it, is to figure out how to specify which nodes your application pod should and shouldn't run on. Tell me your solution in the comments below. In the next video, I'm going to teach you Kubernetes networking concepts that every engineer must know. Subscribe now to get notified of new videos. Keep leveling up your DevOps skills with me. Give me your likes and share this video with your friends. I will see you in the next video.